in the class, so I'm just gonna have you say that one more time for people that are online. I'm gonna do okay, perfect. Can you guys hear us better? Just give us a thumbs up if you can hear us better. Oh, this is cool. Where is the camera? Over here. Oh, I was like, it works, so where is it? Okay. Yes. All right. And then say a little few words more about the program as well. I've heard of it, but I don't know that much. Another person from that same program. Okay, you guys know about the program, but okay, yeah, I don't know. Okay.
All right, I'm Matt. I'm a senior in Science, Technology, and Society program here, which is an interdisciplinary major that kind of spans a whole bunch of topics. I like a majority of mine is management science, and then I sprinkle in a little bit of different kinds of engineering to kind of understand it a little bit more.
And then you build you build yourself. You get to choose.
Yes, exactly. The curriculum is pretty flexible, and you choose kind of the direction you want to go. And then I'm passionate about indigenous rights and sustainable fisheries.
And then Matt, where did you grow up?
I grew up in the Seattle area, in between Seattle and Alaska.
Awesome. I think a couple of threads. Welcome to the class. It's still probably the last week. People could still join the class. We still haven't made team. So again, this is the last reminder. If you want to recruit a friend of yours for a specific project, it's very clear that you're coming in with the mindset like, oh, this is what I want to do, which is what this class is all about. You don't have to have that, but in general, and I think this is also true for the online class. I often see this at the first class, lots of people join in, but then sort of the ones that remain, they are not completely bored with some of the early things that we're doing. So this is my filter, and now I know that this crew is going to be the one that's going to stay, not just for 1 quarter, but for
Hi,
several years
Professor.
before you actually build something with an impact. Can you guys hear me?
I can't hear you very well. Your audio is very muffled. Would you be able to
I'm
use
gonna turn it around. Seems like these things are directional. I was gonna do a quick demo. I don't know how far you guys went in pushing the bounds of this object because we talked about this object. You will learn about this sometime. But one of the important things around it is as you are running your assignment for this week is to make a microcosmos post that blows everybody else's mind. So not a short order. I really want you to not just surprise yourself, but surprise other people in the community. This is a global community, as I said, many kids, and you would realize that many other people will surprise you in ways that you did not think about. Sort of use that as a challenge. Don't push yourself in what you can observe with this. You'll be like, oh, that's an interesting tool. But once you've met that criteria, when you see, wait a second, this thing, then you think it's valuable. It takes a little bit of a practice. These are little cards. I think this is now one of the standard formats. And I just approved the shipping for all of your Foldscopes, so they'll be arriving soon. Shama should coordinate some of that. But you should think of this not just as a, we thought of trading cards. I mean, of course, everybody knows Pokemon. So this to me is Pokemon, but Pokemon for real. Because I've trapped in here something unknown, like you can call it a monster or whatever you want to call it, an unusual object inside. But it sort of creates the Trojan horse in the sense that this as an object I can trade around. I always write them exactly when I made the card, GPS coordinate for my sample, and this becomes a fossil record for years to come. So think of it as a distributed museum of microscopic samples. We have a
Professor,
using Purell, which you wash your hands with, that this sample is then also preserved long-term for genetic analysis. So if somebody in your community...
I can't hear anything.
Can you guys hear me or no?
No.
No,
So
could you use the other laptop maybe for audio?
Let's use the other laptop. I'm gonna connect my laptop and while we do this actually,
we're using the camera microphone.
Okay, No. All right, we are on it. Can you send me the link? Yeah, just like me. Okay, so I think you kind of get the point that this object it's an archival record. So you want to go back and have, 30 of your cards. It's just a piece of paper. But then you can start asking, oh, what technologies can I actually implement in this object itself? And so the Shishto filter I told you about for the diagnostics for schistosomiasis, the innovation was not here, it was in here, where we now filter several milliliters of urine 100 ml or something has maybe 10, 15 eggs. And then you can imagine 100 ml is that much. It's going to be very hard to do microscopy drop by drop. But what we built was a very simple way that now a filter is attached in here. And so you're just watching for, and these eggs are quite large. So suddenly now a tool that was not capable of doing a diagnosis is now able to do the diagnosis. So kind of think about what do you augment in something like this? Okay, I'm going to be online now and it's going to ring. So we will.
Recording in progress.
Yeah, I'll mute myself.
Okay, can you guys hear me now? Just a quick thumbs up. I said a whole bunch of things about this card that I will say again, but the first thing I want to do is I know you guys had fun with Rocky looking at this, and I wanted to make sure that we can do some kind of image collection tricks together as well. And I am looking for a surprise that I saw last night in this sample. Okay, this is good enough. A couple of tricks on collecting data, unless it was already covered. When we run workshops for people, I often don't bring this object out until the very last minute. Why is that? So I will talk about this, we'll play with this, we will doodle and draw what you see, but I don't pull this out. Why? Yeah.
Like in data, like $1 to get
Exactly, because I can't leave this behind. And, it just depends. Sometimes kids will pull out their phones before me, and then it's okay. But then at the same time, so the digital platform enhances your tool that you build, but sometimes you cannot take that for granted. And there's lots of communities that we work, especially with young kids, that sometimes I don't want to take this out because then suddenly they're sucked in by another layer of technology that is not the point. But it is very powerful when they are already users of this because then it augments all kinds of things. So I now have aligned this aperture, and you guys collected some data, right? Yeah. So I've aligned the aperture. I'm in video mode. I'm just on my phone now, and I have my Foldscope. But what I'm going to do is I'm going to do this just as a thread. And now suddenly we are recording and imaging. But I'm just going to show you guys a couple of tricks. And so now this is sort of a blurry image. It's not focused. You might be wondering what you can actually see. So I'm going to pull out another component, which is now just a piece of LED. And I don't know if you guys did illumination. You did some illumination, right? Yeah. Do you have that light source, by the way? Looks like the battery is dead here, which I am bummed about. Anybody else has it?
The black LED.
Nobody has the black LED. Ah,
I'm gonna get one.
do you want to go get one for a second? So we're gonna do improv. I wanted to show you guys there's a trick to do dark field illumination using this, which is a way to improve resolution of your microscope beyond the optical resolution. So kind of, I think what we discussed last time was this simple idea that every microscope will have a certain optical resolution. And it's dependent on a couple of factors, but two very key things. One is how you collect the light, but also how you illuminate the object. And it's very counterintuitive because, when you do photography, for example, the lens that you put on your camera matters, but you should also know that the lighting in the room matters. And so dark field is a magic. You can think of it as a dark magic of microscopy, that you can see objects that are below the wavelength of light. So I can see a 10 nanometer object
which makes no sense if you think about, because the wavelength of light is how many nanometers to visible wavelengths of light? Anybody wants to shout out?
450 to 600.
400 to 700 nanometers is sort of the visible. That's roughly right. You can kind of think about this from the red light to the UV, but then there is ultra UV, there is X-rays, there's all light is everywhere, but visible light. Then there is IR on the red side. There is far IR, which is why you don't see when you turn your remote on. It is actually emitting light, but it is not what we are designed for. But 10 nanometer, 20 nanometer is far below the 100, 200, 300. So think of light as a wavelength, right? And so effectively, it doesn't make any sense if you cannot even define a photon, because wavelength implies that at least there is that much amount of variation in where it's coming from. How is it possible that you can see an object below that? And the trick in dark field is that it's not actually collecting light that's being emitted or absorbed, it's collecting lights that's scattered. So what we're going to do as a trick is try to beat the resolution of this object by only collecting light. So think of everything absorbs light, but everything also reflects light. And your contrast of the image, so the first time when we do this image, you notice there is a little notch here. It's a very simple idea. You see this little notch? And if I move this notch, I'm just going to show you guys, all of you will receive this little trick, but you can build it yourself. All it is an LED and a magnet. But notice what happens here. So now I've moved the notch so that the light is barely visible from that corner, right? Do you all see that? Do you notice this? I have almost closed it, but not quite. And what I'm doing is I'm taking light emitted by this LED in all directions, but only allowing the tangential light beams to come in and hit my object. So what's going to happen is that this light is so inclined that it never enters the lens directly. Only the reflected beams will enter. So anything that will reflect light will be visible. And of course, all objects reflect light. And so things that are even below the resolution of my optical resolution of a microscope can be made visible by what is called scattering illumination. And so it's a little trick. Now, suddenly, when you know that trick, you're like, oh, I know my Foldscope couldn't, like if you were building an air monitoring system using this, some of you know this PM 2.5, PM 1.5. This is what we breathe. Do you guys know this mark of just thinking about? So in air monitoring, there is a type of a mark or a standards that's set, which is about the particle size that you're breathing. So the worst possible one is the smallest one. And do you want to guess why? In air quality and in pollution, why is it that the smallest particles are the most deadly? And unlike microplastic, this one we actually know causes lung cancer. So all the pollution that you see, and many of you who live close to Delhi area already know this, like lung cancer rates are highest in India for this reason. Why is it that the smallest particles, honey, go ahead.
Yeah, because it is then very difficult for our lungs to filter it out.
Exactly,
And
because they go deeper. So we
yes,
have
they go
cilia
deeper.
in our lungs, and the smaller the particle, its mean-free path is such that it'll go in very deep alveoli. And cilia operate like, when you get bacteria, you have all these cilia working. That's why you get mucus. So you might want to detect something that's really below the limit. This is the trick. So now suddenly you can think about, again, going back to we were talking about tricks in physics that you can bring to build a dark field is an incredibly powerful tool. Yes.
If the light was shining straight through,
Yes.
why couldn't it detect the scattering?
Yeah, so that's a trick. It still does scattering, but that amount of light is overwhelmed by the background. So it's all about contrast. So it's a very good question. It is both scattering and absorbing, but the baseline noise is so high. So what we're going to see, if I get the dark field right, we're going to actually see an absolute dark image, and only where there is an object you will see a shimmering light. And so the amount of light coming from scattering is the same but the sensor is detecting the background has gone to 0. That's the trick. Yeah. And I think it's the same reason why nobody goes stargazing in the day. Why don't we go stargazing in the day? Right? Stars are there. They don't show up at night. They're there. But because the background signal is so high, and this is the tricks that you have to think about. I mean, stars don't show up at night. It's like absurd to think about the stars show up at night. But we don't go out there. It's only a function of background because all our sensors that you would put would be overwhelmed by photons that are coming in. So it's exactly the same idea. And so I think one thing we're going to try to do is, let's see, I've built this up now. It takes a little bit of practice. So we're going to just first start with a simple illumination, just that. And I just want you to notice how the image changes. It's magnetically aligned. Let's hover around here for a second. And so if you guys can all come to this side, I'm seeing an image. I'm not very happy with it. It's a little bit blurry. So I'm going to focus. That makes it sharp. And I want you guys to notice certain class of smaller particles that are starting to be visible. Can you all see some of these dots floating around? Right? Oh, and then we have something coming by. Yeah? You all see that? Right. So now, and then I think one thing I will do is just for contrast of the images, it's not going to be perfectly focused, but let's spend a minute. And what's actually happening is gravity is taking over because all my samples are sinking in a way. So what was in my field of view just went away. But you notice some little dots that are there, right? But what we're going to now do is take the same thing and do something super simple, which is take a piece of paper. And I'm just taking a piece of paper right here, and I am attaching that in the middle, right? So what do you think has happened now? When you look at this light, just a simple piece of paper, but it looks different. I'll show that with and without, right? You notice that and that. Just intuitively, what do you notice?
Dims the light.
It dims light. That makes perfect sense. It's reduced because some light has been, but there's something else, like something about the quality of light has changed.
It's a
Like
bit less blue.
it's less blue. You can think about the color changes because, of course, cellulose is interacting with that light, but there's something else. Does it feel like more flat?
More
I mean,
refined almost.
diffused. And so if any of you are photographers, you use those gels on your light. So we're diffusing light. What we're doing is it was a point source, not an exact point source, but there were some point sources of light. And what we have done is we have made millions of reflections inside that piece of paper that now uniform light is coming from many different places. So what we're going to do is just take that and mount that here. And then I'm going to notice that how did my field of view change if I can find my sample back again. Okay, so now you'll notice a fun change in, you remember what we were seeing before? And now suddenly, if you notice, my contrasts, my colors have all completely changed. Do you guys notice a difference? Right? The background is much whiter. Some of the objects that were visible have actually disappeared. Some of the smaller objects that were floating around. But on the other hand, I have much sharper description of what's actually was visible in this particle. And so just as a contrast to what you saw before. Oh,
I want to try to.
yeah, we can switch.
Aperture.
Let's switch apertures for
Yeah.
a second. So we're gonna try. This is pretty cool. I didn't know phones can do that.
Yeah.
Aha.
I'm
Okay.
just sharing the screen.
Yeah. Which camera?
I have to use the top one.
This, are you
Yeah.
sure?
Yeah.
Okay,
And
I want to
you
be
have
in video
1.9,
mode.
My experience.
I want, oh,
Go to-
recording video not allowed.
You need to go to video.
Okay, I do. I see. It'll still show the
yeah.
video. That's good. Okay.
Yeah. Exactly that.
All right.
Exactly
And
that.
then this.
That one. Yeah.
Okay. And then this is the art. You kind of have to actually align it by eye. What am I seeing here? It's embarrassing. This is all being recorded, right?
Yeah.
Yes. Okay. Now we go in, and most of you are watching that, and there.
Yeah,
Awesome.
we can see.
Oh yeah, the video view is like more.
Yeah, we can see.
Okay, so kind of one of the things that I want to mention is, oh, okay, it's doing some funky business.
Yeah.
Sometimes when I am doing data gathering, what I'll do is I'll take a stack of paper and I'll use the stack of paper or a book as a way to now balance my much thicker. This is too thick, that's too thin. I use
So
this.
it's like, I'm gonna try to disconnect
It's
it.
okay. It's oh, it disconnected?
Yeah.
Is
Let me
there a
see.
way
Yeah.
to get that back while I'll do the dark field now for a second. So you all saw that there was a change. And we're just doing very trivial things that anybody could just do and play around. And what I'm trying to say is microscopy is about two things: how you collect light, but how you illuminate your object. And the actual resolution depends on the numerical aperture, which we'll talk about in the next lecture, of both illumination and collection. So you multiply the two, and now we're going to do this trick. Is it back
Yeah,
again?
it's back, yeah.
I'm going to now go in what I think might be the dark mode, and I'm just going to test that. Yeah. Oh, did it disconnect again?
Yeah, that's okay.
Let me try. I think people will get to play with this because I want to jump to the lecture in a second. And so one of the things that we will now do is just show you that dark field. And the only reason I'm doing this demo is I want you to play with the tool. Don't think about this is a theory I know or I don't know. No, just mess around with it. Put like 30 different types of materials in there, put different types of illuminations, just shine light at it in funny ways and discover for yourself almost accidentally a mechanism, and then you can go back and understand it. So there's a little bit of this is like call this a undisciplined way of learning. I know you guys are very good at disciplined way of learning. I'm not good at teaching the disciplined way of learning. I don't learn that way. I learn by tinkering. And so I want you to make sure that the tools that you're using, and I think this is a general statement. Maybe people can show of hands who are good at undisciplined way of learning. Anybody here? Yeah. You just mess around and see what happens. Yeah, it's a good thing, right? And we are naturally born in this way of some people need a very systematic, get the whole picture in head, and then you say, it's a little bit like you like climbing and you will plan your route and everything, and then you go and it's perfectly fine. But sometimes people just go out and like getting lost and then find your way back, and that's how you discovered a new territory. And I think this is what we're doing here. So just kind of to build this up. Now, when you come in and come closer here, and I'll show that on the lecture in a second. But now what you're watching is there is do you notice the little dots that are appearing there now? Those are individual bacteria. They were not visible before. Do you notice that little black dot that's showing up like stars in the sky? Do you notice those? And notice very carefully, now there are thousands of them that are shimmering. And I'm going to try to actually stabilize this for a second. Ugh. Okay, we go back to our sample right there for us. Did you see that? Right there. Do you notice that the field is almost filled? Those are individual bacteria. Do you see them? Even the smallest ones. And right, did you see it? And as they're swimming and as they even change their orientation, they reflect different amount of light, and that's why they're blinking now. And one of the key things is that this sample is filled with bacteria, but we were not aware of it because it's just at the resolution cutoff, because many bacteria can be smaller than a micron. The resolution here is 1.9 microns. So everything only above that was visible, but now suddenly we're seeing things that are much, much smaller. And kind of one of the things is all we did is, and then you can see here is the bright field and that's the dark field, right? And if I focus it, then I really, and actually, what I was hoping was also to show you some motile bacteria. So if now, I know some of you had mentioned saliva. If you were to do this test with saliva, you would see in your mouth. So try doing that. And then maybe we can make an index of who has more bacteria. And there's nothing wrong with it. It's like, it is our microbiome. You would not, yes,
When we
question.
get the sample of a cough, because you mentioned the cough.
I can do that. And I think this is sort of,
No, but there's like, you said there's like the needles. Right?
that's correct. So now if I go online, I'll show you in a second, but the idea is to not think too much sometimes, like just try. So how many ways you could get, I just have a piece of tape and I'm just gonna stand here and that's it. And I have my cough sample, and then you just put that on. And if you are more sanitary, then you can wipe it off or clean it, whatever. But I have gotten my cough droplets in here. And actually, I looked at it almost 10 years ago. So I'm going to check whether my cough still is shooting needles. And I had posted that on Microcosmos, and there was a doctor. And he's like, oh, do you know that these oxalate crystals are actually related to some conditions and things? I never followed up on it, but I learned something about myself. And now I'm not seeing too many big droplets, but it's really funny. There is a technique that Enrico and I are working for microscopy that's looking at what we call ballistic microscopy, and I'll talk about it someday. But do you guys know how fast cough droplets move when you cough? Anybody? Let's throw a number. What is the speed? Anybody wants to raise their hand? What is the actual speed of a cough droplet?
60 miles an hour.
60 miles an hour. How much would it be in meters per second?
Yeah, my guess was about a meter per second.
Meter per second? I want to show you guys. I think my intuition is that's but what we're going to do is I'm digressing, but again, it's an important thread to think about. What just happened?
10 miles per hour is 26 meters per second.
So what you just saw is kind of high-speed imaging for these cough droplets. And these are shooting out, I think meters per second is roughly and of course, everybody studied cough in the context of COVID and other sets of things. This is a good one. Now, this is another technique. It's called Schillerian, and you're shooting billions and billions of these tiny droplets. But this is in normal talking. But when somebody coughs, this shoots out. And actually, what I can see in what I observe right there, I'm seeing almost these little splats that these droplets hit the sample and kind of like blood, they form these little, I don't see any crystals in it right now, but you might want to cough more when you're play with it. But I think the important part is you have to very quickly go from, oh, this is the idea to how to make a sample or how to visualize it. It's part of the assay itself. And you have to invent it. It's not something that like I want to watch how this pen writes. So I'm just going to doodle it out, put that in, do now that for 30 different types of pens to then understand what might be going on the tip. It's not, I mean, I think in microscopy or in some of the sciences, you're sort of told the entire protocol. Here you are inventing the protocol. And there's no right or wrong answer because once you start doing it many different ways, you will find, this is the thing I wanted to visualize. And I think one thing we will now transition to diagnostics, but one important thing I want to mention is in diagnostics, this is one of the biggest bottleneck is how do you get the sample in the right concentration in the right way? Like I had talked about urine for a second. You can think about, oh, earwax. Like, can we learn something about a human from earwax? That's now suddenly you're dealing with a new sample. You're dealing with like, oh, I don't know if you guys know this, but if you take a Q-tip and stick it in your nose, which all of us have done for COVID, there are ciliated cells, epithelial cells that you get, and you can actually diagnose ciliopathies whether somebody's cilia are working properly or not, which are much deeper in the tissue, but in the nose, they're available right here. Super easy as a test, but you can kind of build. And so when you're starting to play with these tricks, you will learn uh, how do you go about preparing your sets of samples. And then I think one important thing is all of you have access to glass slides and cover slips. This is very low resolution because this is plastic. So it has all kinds of aberrations. So the optical resolution of a Foldscope is really designed for glass. So you should transition. And I think we do this because, of course, this is backward compatible technology in some sense. And we now have modules for doing cover slips of glass even in this because it's just easier to transport, carry, mark. But you guys, I'm expecting you guys to do like take as many glass slides that you need to take from the lab and make your slides. And the other last thing about this assignment is it's a little bit of an archival thing that the more you do this, and the challenge that I have for the whole class, the folks online can join in that challenge when you guys receive your Foldscopes, but for everybody, try making one observation per day and do that for 30 days in a row. And I'll
Of course,
see how many of you finish that challenge. I know you might finish that challenge talking to you last time. 30 days in a row, one new sample every single day. And
can
then
you open the form back up for the folks online to request the fold scopes?
yes, absolutely. I think
Thank you.
just send a message to Enrico. Yeah.
Yeah.
Yeah. But I think the reason I just mentioned this is because I had posted this challenge because I did this for, I think I'd done a 60-day kind of consecutive workshops. And then I got a message from one of the users in Iraq, and that's Muhammad, and I'm going to show you his picture. And he ran Foldscope workshops in his community, new things every single day for 141 days in a row. And so kind of he holds the record in the Foldscope community right now for consecutive. So this is, you'll see right here is Muhammad. This was right after the Iraq war had ended, and he's in Kirkuk. So some of you remember that name. He had started the first science club in Iraq at that time. And again, he still continues to do this. And the reason I'm mentioning this is, you might think that, oh, this is science education, but what he started documented. So now if you go on microcosmos.foldscope.com, I can type Kirkuk or let's type Iraq. Uh, and you notice this is sort of, he's giving a talk about this, but if I click here, you'll see all kinds of posts coming from him. I like this one. This was day 6 of his challenge, and that photo is kind of funny uh, because the kid thinks that they can see, but no amount of looking on the side can you actually see. But his posts and his writing around this is actually about Shia Sunni conflict, about trust, about arriving in a community and being felt that, oh, you don't belong because trust had eroded. I mean, in a war, what do you expect? Nobody trusts anybody. And so, kind of, although he had started this first as an activity in terms of thinking about science education in Iraq, he ended up sharing much more of, oh, how do we really build that community trust back? Because the conflict was so polarizing. I mean, people had some control on what they could do, but there was a lot of things that were not in their control. And so him arriving in a neighborhood that he was not known in beforehand was very tricky. But on the other hand, that is exactly what he wanted to do. Because at the end, so kind of the reason he started the challenge because kind of schools had shut down, but he continued the challenge because he was challenging himself. Like, why am I considered an outsider, even in a community that I have lived in and grown in? So I think this is kind of the point, is we have an infinite supply of Foldscopes for any of you. And the purpose of this one is a little bit outward. Amongst most other projects we will do, we'll be trying to solve a technical problem. But this one has an outward component that what I would like you to do and think about is once you have mastered the tool, think about one community that you're dedicating time, whether you do that online while you are here. I'm willing to ship hundreds of Foldscopes to any community that you care about. So this is now even going beyond that 30-day challenge that I said, oh, I'm at Stanford. I have every possible thing I can imagine. What is it that you get to transpire and then still engage as a mentor? And I can't do that. Like, I would not be a good person to run and operate a program like that in a Native American community, but you would. And that's sort of the transition handoff point. So the ownership of this project doesn't belong at Stanford, doesn't belong at any individual member. It belongs to like Mohammeds of the world, because at the end he decided that he wanted to do that. I've never stepped even in Iraq. Like the closest I've been to maybe is Jordan, but never actually been there. I would not be the right person to execute on that program. But think about this, because at the end of the day, and it can be very small, it doesn't have to be, it's like, oh, I'm starting a big NGO or nothing. Enrico was home hanging out with his family, and then he ended up running workshops in Italy, and he got the full scoper of the month. We do this as a community. We celebrate one person a month. So this is another challenge to all of you. Let's see. After the 30-day thing, if you can pass that bar, you can actually be a Foldscoper of the month. Then the highest degree that we have in our community is a Foldscope fellow. And a Foldscope fellow is a person that has essentially understood the idea that curiosity is at the heart of invention, and curiosity is at the point of, and is spending time with sets of communities, dedicating their time. And most of them are volunteers. There's nobody paid in the community. But some of the Foldscope fellows, and I'll end the Foldscope chapter because I think I told you guys the technical part, but I forgot to mention, or I didn't have the time to mention the social aspect. So I'll mention this individual. You can see this individual. That's all the way at the back. His name is Mo Pandirajan. This happens to be a photograph from a rural part in South India. And maybe around 8 or 9 years ago, I had gotten one email. Enrico knows this. I don't read email. I just can't. And accidentally, I read this email. It was in Tamil. I don't speak Tamil. It was a 4-line email saying, I am running a 14, 15 children's school, and would you send me some Foldscopes? This was when we had announced the big program, the Foldscope, the first program of 100,000 instruments. And then, I wrote to him, I wrote back in Tamil using Google Translate. I started shipping Foldscopes. And then a couple years later, I got an Excel sheet from him saying, oh, Manu, I just wanted to report. And then that Excel sheet had 100,000 names. And this one single individual over the last 4 years has trained around 95,000 kids. And actually, that number is around 125,000. This is 12,000 teachers across the country. One single person. I didn't believe him first. And then when I don't believe somebody, I do a simple trick. I became Facebook friends with him. And I checked every single day. He was running workshops for 100, 200 kids, taking trains across the country, just traveling, stopping at places that he didn't know. Even in the trains, in Indian weddings, he was running Foldscope workshops. So now if you go on Microcosmos, he is the only individual that has actually, I believe, crossed me in the total number of posts that he has in the community site. And Pandi, I'll see whether, no, Pandi Rajan. Okay, that's Mo and I, but this is me describing that. And I'm trying to look for his handle. Madurai. No, Madurai. No. So when you spend some time, you'll kind of find, and actually, it was NPR did a story on him recently. So, and so one of the things about that is NPR got the news about this, and then they sent a reporter who hung out with him for some time. And kind of one of the threads around this is so that's kind of an important aspect of this is driven by that Foldscope fellows are sort of the highest level in our community, which is driven by that they are thinking so deeply about the community that the tool is only a means to what they're trying to achieve in their community. But so now, once he did this, then he started introducing astronomy in the community. He started introducing a book club, and that's been growing in his set of a community, but also just the documentation for this. So one of the expectations for all of you is make sure that anything that you do with this tool, you document it, because there is a massive group of people who are using these tools. Like literally today morning, we ran Foldscope workshops in Ghana because Elisa happens to be in Ghana. And so they just sent me these WhatsApp images. So anything that you post here is being live also utilized. And for many of you who have kind of scientific access, you could be building the sets of protocols, you could be building sets of things. So this is not even in the context of the projects that you do, that anything that you document well. For example, if you have interest in the artistic side of this, look at what you see. There is a projection mode that I don't, do you guys cover it?
Oh, yeah.
So look in the back of this or search in the website. You can make projection microscopy, and actually maybe I can show that here. Foldscope projection microscopy. And then what I do is with just a little light, so there's all kinds of videos online on these modalities, and I haven't seen this, so I'm not going to click on it. But this is basically how to turn a Foldscope into a projector with a flashlight. That's another example of that. That just you attach a flashlight to it, and what that does is that it gives you a way of thinking about drawing what you see. So also in the microcosmos community, there is an artistic community that actually doesn't take pictures. They only draw what they see. And because once you do a projection, then it becomes a camera lucidia, which some of you might have seen. So I'll just do that. Microcosmos. I'll show this one more time. If I do camera lucidia right there. So this is from a 7-year-old. This is a fairly old. Lax is also another Foldscope fellow, and then he has a video of how to convert that into, and then I'll do another one, camera lucidia, drawing onion cells in real time, use Foldscope in camera. Okay, so this is a post that I'd done long time ago. This is from 2016. This used to be an old technique where before the invention of cameras, how the hell did all these biologists make incredibly accurate images? So the trick here is that there is a beam splitter here. So if you notice there at that, there is an angle. So his eye, some of the light of his pencil is coming straight, and some of the light is coming from the microscope. And when you get combined, you see, there's no projection here, by the way. You see the image just like you're drawing. The way we do camera lucidia with that is we actually project a real image on a surface. There is no real image here. This is just the beam, but you see your pencil and you just draw. And so this was the common technique, and kind of this is the Foldscope version of that. This is a $2 keychain with a projection, and then you notice this is essentially the projected image, and then I am drawing this using projection, and then this is sort of what you would capture on your camera. But it's one of the important aspects around this is that when you do this, a lot more goes into your brain, because bits don't just go straight into the camera and then you're like, oh, I recorded it. You have to pay attention to what you're actually seeing. And I think this is an important key aspect for everybody to be thinking about. This was another version that we had done in the lab. So this entire image is actually a projection image of a bat star larva. And there's all kinds of tricks around projection microscopy. In fact, it was one of the earliest versions of microscopy was done using projections, because people had understood pinhole cameras, and then after that, pinhole cameras kind of started bleeding in. So a lot of people were thinking about projection as an approach. They would put a little droplet in a pinhole, because pinhole photography was what Vermeer, I don't know if some of you guys know this history, Actually, maybe I will show you guys. Everybody knows Vermeer, right? Vermeer paintings. Uh, Actually, this is useful. Do you guys know what Vermeer is famous for? I'll choose my favorite Vermeer painting, and I have a point to make here, so bear with me. Uh, Let me ask you this. What you're looking on the right, is that even a painting? I would not have shown you this if this was not a painting. But Vermeer invented photorealistic paintings. And mystery, and now again, I don't have any evidence for this, but I'll just still state it. And there's a lot of work that's been done in the optics. How the hell could somebody do this? Right? And it's believed Vermeer was one of the first amongst the very few because his perspectives were so accurate that people have gone to those places and taken photographs and they were correct. But it was super secretive at that time. So it's believed that Vermeer had either learned or invented these projection techniques, that he was drawing what he was literally projecting on his canvas. And of course, he was a remarkable artist. And guess what? The other person that was living right next door neighbor, and there is no evidence for this, but I find this really hard to believe that this would not be true. So I'll just state it, but there is what I'm about to say has no evidence. Leeuwenhoek, who invented simple microscopes, was next door. He was in the same town. He was living right next door. And Leeuwenhoek was talking about basically the first microbes. He's the one who invented and kind of there is a lot in the history that's actually documented in terms of thinking about uh, maybe I'll show this picture. Leeuwenhoek. Okay. So this is, and I'm just going to show you this one picture because this would become as an important criteria. So that's Leeuwenhoek. And of course, not many, I mean, of course, there were no photographs. These are some of the very few of paintings and kind of that exist of him. And this is his microscope, and it's actually valuable if you go back to the design. He was the first person to understand that. I mean, first of all, he is the inventor of microbiology. He's the first person to see bacteria. He's the first person to see everything, actually. Because if you invent a microscope, of course you're going to. But ironically, the technique that I had talked about in the first class of using very high curvature lenses. So there were two types of microscopes that have existed. There is something called a compound microscope that has many, many lenses. And then this type of an approach is called simple microscopes. And so guess what? What came first? Compound microscopes or simple microscopes?
Simple.
That intuitively would be the correct answer, but that is not the correct answer. Compound microscopes came first because Galileo and many other people had invented telescopes. And they started looking at them in these sets of arrangements, and then they arrived at an arrangement of lenses that could magnify things. So Robert Hooke was using that. But when you have more lenses, you have more aberrations. You cannot align them perfectly. So their images were blurry. So they never saw single bacteria. What we just saw, they never saw that. And then Leeuwenhoek went the other way. He accidentally discovered high curvature lenses, but only one lens can actually give you resolution that far supersedes compound microscopes. And this was his challenge. I mean, Leeuwenhoek was also the very first citizen scientist because he had no degrees and nothing. So he was writing to the Royal Society, and they're like, who the hell is this guy? He couldn't write in Latin. So of course, nobody believed him. If you couldn't write in Latin, people were like, you're not serious enough about what you do. He was a merchant selling cloth, and he actually ended up completely flipping the entire field of microbiology. For the first 10, 20 years, nobody believed him. They would send him people, and then, he would go back. But he was also super secretive, which is also the other thing that we do in our community is the opposite of Leeuwenhoek. Leeuwenhoek famously said, and I'm going to say this, and none of you are going to like me for this, but I didn't write it. He famously said, I am yet to meet a young person who's passionate about science for the right reasons. Everybody I meet is in there to make money. so I am not going to teach anyone. And he died not teaching anyone how to make his microscopes. And guess what? He was just serving himself. Because if you're the first one to see everything, why teach anyone when you can get the fame? And so I think science operated. And actually, because of his death, and because he didn't teach anybody how to make his lenses, and then those lenses got burned, we only have a few left. Cell biology and the field of science of just discovery of cells are actually back shifted almost 150 years. 150 years past that when we were able to come back to that resolution. And then, the invention of cell theory comes after his death. So it's a little bit ironic when you kind of think about from tools and technologies, like what we are doing around us. Many a times, I mean, you could take that same example and apply it to closed AI models and all kinds of, I mean, now there is capitalistic framework on this front, but from a scientific frontier point of view, if AI was the frontier for pushing science forward, why would you not really kind of make that accessible? Okay, I know some of you have to run, but kind of the big thread around this is try pushing the bounds of your microscope. And what I'm going to be looking for is see what you can document and discover something new with that tool, but document your process. And like your first images are not going to look the most spectacular, and that's perfectly okay. But I think the purpose of this as a tool and the reason we're spending a little bit of time on this, and I think most people online, you guys will get a chance to do this assignment as soon as your Foldscopes arrive. And I think we're going to try shipping in a day or two. Is this notion that this is one space where you will get to better understand the role of community in your projects. So you're kind of not working alone. There is a massive community that you are influencing, making them in kind of different directions. So choose sort of any topic that you care about, document what you want to do, and then post certain sets of things that also challenge other people to repeat what you do. Yes, comments. Can you remind me your name? Jesse. And I promise you, at some point of time, I will remember names, but it's going to take me a few more classes. Go ahead, Jesse. Yeah.
Gotten such sustained interaction from kids because usually kids get a toy and then they'll get bored of it.
Yeah.
Like over a month. But
Yeah.
how have you continued that?
Yeah. I mean, that's a challenge. I have my own kids, and so kind of I struggle with that all the time. I think the way to think about sustain is like Foldscope doesn't have any experiments in this packet. It's a little bit of making sure that you're tuning something to be open-ended. There's no lesson plans we force kids to go through. So this is just a window into a world, and where you point to it can change every week, every month, their interests change. It kind of dies out and comes back. So it's a little bit of a Trojan horse. Like I think the analogy that I have often given from a design point of view is I've been inspired by the invention of a pencil. Pencil doesn't tell you what to write. Like you can doodle, you can sketch, you can draw. It's open-ended. So how, from a science education perspective, which is kind of the case study that we're studying, try designing open-ended things that people bring their lived experiences and their purpose to the tool, rather than us kind of boxing in a thing. And one of our challenges, culture is so broad. Like if I was to design an activity, it'll work in Palo Alto, it might not work in Ghana. So what we do is kind of provide the resource and get out of the way. But there is a bridge, which is the Pandirajans and the Mohammeds of the world that act as a bridge. So they are the ones that translate what could be done by everybody else into the language what might be relevant to a local community. Like my daughter was writing an essay on kind of Native American art recently, and I kind of gotten obsessed by these geometrical patterns that are everywhere. And I was like, is there a root in nature that people might have seen these? And then suddenly you go about and you ask yourself this question is like, oh, geometrical patterns are everywhere. So maybe the approach that I would build in that community is to search for these kinds of geometrical patterns that are part of our lives in a landscape that is invisible to the community as yet. And so suddenly now I have made a connection between microscopy and just geometry, symbols that might be relevant to people. So But that is very hard to do. It takes time. But I think the key in if many of you, I'm hoping some groups will choose science education as a primary project space, that you're thinking about being open-ended. I think that sort of is the root. Yes. And then can you say your name again? Nikita. Okay.
I was wondering,
yeah.
well, two questions. First, I feel like one step of it is like getting the picture itself.
Mhm.
And I wonder for communities, in terms of like analyzing the samples that you get, like are there online softwares that can just like upload the picture and like how do you
Analyze.
use like after?
Yeah. So there is a Foldscope app right now, and you can play with it. It'll give you a kind of a sense for, so that's the Foldscope app. There's a couple of things that are built in here in terms of analysis, but not all the features that exist. And so I think one of the things we're excited about is to expand the capacity, because now compute can be added as a layer to it. And a lot of times when you don't know and you want the compute to help, that's super useful. There's a lot of scripts also that people write in terms of thinking about just analyzing data, segmentation, and other sets of factors. I think when we designed the tool earlier, we had assumed this will barely be existent. But now this has gotten so good and the compute has gotten so good. And it might be that the application that you might come up with or imagine only works by the combination of optics and compute. So think about everything that in the old days you would do with optics. Now you take away the capacity of the optics, not completely, but you reduce it, but you add compute to it to balance that the final product or the outcome is exactly the same. And it's a very powerful approach. And I think it's called computational microscopy. So people can enhance contrast. Computational photography has been there forever. I don't know if you guys know this. Every time any of you take a photo with your phone, it's not real. That doesn't exist. What you took a picture of is you have no access to the raw pixels. It already has 15 to 20 different algorithms. It actually many a times will take a picture which will blend multiple pictures to get you a perfect focus. So that object in that shape didn't even exist. And so computational photography has become so advanced now that we have accepted it as a fact. And only most phones will not give you your raw data. Only in high-end SLRs you can extract those raw pixels. That if you just want to say, oh, I want to capture reality, you don't capture reality anymore. And, I think from a perception point of view, it's useful, but there is also a problem in it too, because as long as you don't have the raw data, it's possible that you might miss certain sets of things. So compute is a huge part of it. And in your specific explorations of Foldscope, focus on the compute. And compute is less used so far in our community because everybody's phone is different. But if you bring it, then on the cloud, it's much easier to do. Also, all Foldscope data, by the way, is open and public, and you can download it, and then you can process it with all kinds of compute. So if you are really good at handling large data sets, we have terabytes of data set from the community, and there's all kinds of tasks that we do, in terms of autofocus. There is 3D photogrammetry. I have some algorithms in which you can take a Z-stack and convert that into a microscopic, fully focused image. Because sometimes some parts are in focus, other parts are not in focus, but you can do a very simple Z-stack by moving this, collect it as a video, convert that into a photograph that is focused everywhere. Very simple task. So play with it. I think kind of think about how do you handle your video data.
And can we?
Yes.
I don't at least have access to like the LED.
Yeah, I think one thing we should do is give everybody the teacher pack.
Yeah.
Yeah, and I think in the shipments also, it's the gray pouch. So talk to Shama a little bit about it. That's the teacher pack. It should have all of these units. And we should make sure that Matt has another one too.
Yeah. I came to the lab on Friday.
Oh, you were there.
Yeah,
Awesome.
so I was
Awesome.
there.
Awesome. Okay.
You can take this one if you want after class. You can follow me and then
Yeah,
you get,
I think,
oh yeah.
yes, haha. That's why you should write your name. And you can either keep my cough sample or you can remove it. Oh, it's in there. Yes. You don't want it?
I do that.
Okay. All right. Any questions, comments? This is open mic. And I think Friday we're going to do a demo for the malaria diagnostics. So please try to be there. It's a super awesome demo, and then I'm gonna do a lecture. It's this Friday here, 9:30. Yeah. And then you should coordinate with Pranav to make sure we have the latest version.
You want the octopi or the squid?
Which one were you thinking of doing? Because you attached this octopi paper.
Yeah, that's true.
Let's do octopi first so that you get a little more time with the squid, and you and I can work a little bit. Yeah, we could do the demo in SciCube then.
That could be great.
I think let's do that. Yeah, let's do that. Yeah. We will send a new location for the Friday demo.
Yeah.
Okay.
Different spot out here?
Yeah,
No,
it's in another lab space, but still on campus. Any questions from the community? You can raise your hand just so I know. So I have Honey as one hand. Anybody else? Okay, Honey, go ahead.
Yeah, I just wanted to ask that if we want to ship the Foldscope, the teacher kit to Bangladesh, maybe, so can I do that? Can I get some time to just arrange the addresses, because we have an NGO that we would like to explore that how we can use it to have a awareness workshop regarding the
Yes.
drinking water.
100%.
yeah.
I think, Ani, my biggest challenge often ends up being in the shipping and logistics. So if you can take care of
Okay.
it, if somebody is flying from
Okay.
here to Bangladesh, it's super easy to just carry them with them. I often carry
Okay.
100, 200 full scopes. I write a letter saying that
Yeah.
this is for kind of broader sets of purposes. I would even be excited about once you do a quick pilot. We currently have a phase 2 program running where we are deploying, maybe of the order of 500,000 Foldscopes around the world. So if you are ambitious,
Okay.
I am super excited about implementing 5 to 10K per
Okay,
community.
so can I get two Foldscopes so that one I can plan, or I
No, you
can
will all
find
get
out.
20, 30 Foldscopes in the first
Okay,
shipment.
okay,
This is not one or two. One or two doesn't help. So,
okay,
but
okay.
I want you to be thinking about larger scale implementations.
Yeah, sure. Yeah. So that would be the main purpose, because we are
Yeah.
trying to plan the workshop soon. So I want to use it for the community level awareness. Maybe
Yeah.
we will
And
not
then,
be able to see like the E. coli or such pollutants, but still the microbes are biggest pollution in
no.
Bangladesh.
I think WASH programs, if you're running anything on sanitation, we ran a very large program in Tanzania. So we have the
Okay.
entire protocols, all of that is documented. If you just search Shine Project Tanzania,
Okay. Okay.
Shine
Shine project. Okay.
Project Tanzania.
I'm gonna go down.
Yeah.
Check them.
Yeah.
But I won't put the. I'll
Yeah,
just upload
just
stories.
leave it here because I already